Assalamualaikum warahmatullahi wabarakatuh and good morning. So today our group will be presenting about bending error. The finished angle of sheet metal parts is consistently incorrect due to bend allowance calculation errors. So firstly, what is bending error? So bending error is a problem that occurs when the final bend angle or shape of the sheet metal part is not as required. This deviation can involve, first one, incorrect bend angle. The resulting angle, for example, is 92 degrees instead of the required 90 degrees. The second one is incorrect bend radius. The internal radius of the bend is too sharp or too large. And last one is incorrect dimension. The resulting dimension, such as the overall length or the position of features relative to the bend, are off.
Main causes of bending error, got 5, is first, wrong bend allowance BA or bend dedication BD calculation. Second, incorrect K factor used in calculation. Spring back. Third, spring back not properly compensated. Fourth, incorrect tool radius, punch or die. Fifth, material thickness variation. Bending error mainly happen because several related factors affect how the sheet metal deforms during the bending process. Wrong bend allowance BA or bend dedication BD calculation occurs when incorrect formulas, unit or estimate value are used, because the flat pattern length to be inaccurate. An incorrect K factor is often chosen because the actual material properties, thickness or bending method differ from standard value. Spring back is not properly compensated when its effect is underestimated, which usually happens due to changes in material strength or lack of test bending.
Afterwards, we're going to talk about reduced bending errors. Reducing bending errors in sheet metal fabrication is a crucial process that relies on a combination of precise calculations, proper machine setup, and material control. And how we are going to do this? First, we need to use a correct bend allowance formula. The bend allowance, which is BA, is the length of the material's neutral axis within the bend radius. Calculating it correctly is essential for determining the flat blank size of a part before bending. An incorrect calculation will result in parts that are too short or too long after forming. Second, we need to use the correct K factor for each material. The K factor is a dimensionless ratio that defines the location of the neutral axis, which is the layer in the material that neither stretches nor compresses during bending, relative to the material thickness. Third, we need to ensure accurate tool setup and alignment. A well-maintained and accurately set up machine is foundational to bending precision. Fourth, we need to perform test bends before mass production. Creating first-off pieces and verifying their dimensions is a crucial step before committing to a full production run. And lastly, we need to maintain consistent material thickness, because the variation in material thickness, even within standard manufacturing tolerance, have a significant impact on bending results.
Next, the key formula uses for bending allowance is BA equal theta time (R plus K dot T), where theta are in radian, R is inside the bending radius, T is material thickness, and K is fractional distance from inside surface to neutral axis.
In conclusion, bending error mostly happen due to incorrect bend allowance calculation, which can cause the flat pattern to be either too long or too short. This error becomes worse when the wrong tooling or machine setup is used, as the punch radius and alignment can influence how the material will bend. In addition, if spring back is not properly compensated, the material will open up after the bending and produce a larger angle than we want. By using accurate data, selecting the correct tools, and applying consistent quality control check will improve the bending accuracy and ensure that the finished part meet design specification. That's all from us. Thank you.